Let's look at our last concept in experimental design called blocking. And this one is, let's look at our last concept in designing experiments called blocking. Can't stress enough, look at your textbook. Please look at your textbook. Read those examples as well. So suppose that a mobile phone company is considering two different keyboard designs, A and B, for its new smartphone. The company decides to perform an experiment to compare two designs using a group of only 10 volunteers. I probably would use more than 10, but okay. Each volunteer will test one of two designs. The response variable is typing speed measured in words per minute. How should the company deal with the fact that some of the volunteers already use a smartphone while the remaining volunteers probably are not as experienced? They could use a completely randomized design and hope that the random assignment distributes the smartphone users and non-smartphone users evenly. However, with only 10 people, that's very unlikely. You could definitely end up, because you've only got 5 people in each group, so you definitely want to make sure that you're more balanced. Okay, so we want to reduce this variability. So what should the researchers do? Okay, so they should identify the experienced and non-users and place them into separate groups. So the experienced smartphone users and the non-smartphone or the novice, and place them into different groups for randomization of treatments. So I believe in the next example we're going to see that 4 people were experienced and 6 were not. So of those 6, we're going to give 3 of them the new keyboard, 3 of them the old keyboard, and of the experienced, we're going to give 2 of them the old keyboard and 2 of them the new keyboard. So that just really helps out. So it's going to allow us to account for the variation in experience, because we don't want experience, or honestly, if I were going to modernize this question again, I would say maybe the amount that they use. So like, already their texting speed, maybe separate them by texting speed as what they have already, or how much do they text, how much do they type on there. So there might be some different ways I would split this up at this point in time. So this is kind of an outdated question. So I'm going to move down to this next paragraph, the one that starts right here, to see how blocking helps. Let's look at the results of the experiment using just 10 volunteers who already use, 4 already use it, 4 do not. So here, let's see. Okay, so right here, okay, all right, we're just taking a look, and so design A is the new keyboard, design B is the old keyboard. Okay, so it says each of the 10 volunteers type the same passage and their typing speed will be recorded. So there's some evidence that A results into higher typing speeds, but it doesn't look like it's, when you only have 5 people in each group, it's not really a huge difference. Okay, so let's take a look at the next page. Okay, I might just look at that and go, well, is it really worth our time and money to change keyboards if it's really not showing that big of a result? So let's take a look here. All right, now it says blue and blue squares and gray dots, but on yours, since it's a printout, it probably is only squares and dots. So the dots are the novice or the inexperienced smartphone users, and the squares are the experienced smartphone users. So we can see, if you just look here, there is a much greater margin of difference. In fact, the lowest person here matches the highest person on the older keyboard. Same results for the experienced users. Aha! So that's one way, is just look at the two groups separately, and I kind of like looking at it this way. But then they went even further. They looked at how much faster the experienced users were, and they actually subtracted that difference from their time and moved them down. So now you can see when adjusted for experience, this cluster is much higher than this cluster, and we might even, after doing a little more research, we might find that that is a statistically significant change, although it's hard to tell with only 10 people. I can't believe 10 people in a study. That's just crazy. All right, so, but it happens all the time. All right, so because we accounted for the variation caused by the difference in the smartphone experience, the variation in each of the distribution has been reduced. There's now almost no overlap, so there's very minimal overlap right here between the two groups, okay, between the two treatments. So when blocks are formed wisely, it is easier to find convincing evidence or statistically significant evidence that one treatment is more effective than another. Okay, so let's take a look. Blocking in experiments. Okay, blocking accounts for a source of variability, just like stratifying when we're talking about sampling. Okay, this means that blocking is another form of control. Blocks should be chosen like strata. The units within the blocks should be similar, but different than the units in the other blocks. You should only block when you expect that the blocked variable is associated with the response variable. Blocks like strata are not formed at random because we specifically choose them. So what were some variables that we could block for in the caffeine experiment? And in general, how can we determine which variables might be best for blocking? So the first part of this question, what are some variables that we could block for in the caffeine experiment? Actually, male and female. Females do tend to have a lower pulse rate than men do, so we might want to block for that. Also, athletes versus non-athletes. Somebody who works out a lot or trains for a sport tends to have a lower pulse rate than people who are more sedent and just play video games all day. Not saying that we have anyone at ATEC like that. Nobody. Okay, so the second question, how can we determine which variables to block for? It's really just have to think about it. Try to think of other factors that could influence the responses in your study. Okay, so our new revised summary, think of all possible sources of variability in the response variable. Control everything you can, block for the things you can't measure, you can measure but can't control. And randomly assign treatments within those blocks to balance out the effects of any remaining variables. All right, so yep, I did say that this video shouldn't be as long as that second one. So let me see if you have any comments or questions on here, and we are done with 4.2.